Welcome to Turn Right Machine Works. My name is Keith, and here we go, starting another season of walking the talk and getting her done. Now, the first video here of 2015, I want to go ahead and recognize another company that has been walking the talk and getting her done since 1900. All right, now we're going to be doing a little boring in the lathe, and we're going to be doing a little milling in key weight slot cutting in the K&T. But before we get started on this video here, I want to go ahead and change out of this shirt and change into another. I'll be right back. Yeah, I like the color too. Lovejoy is the company that has been walking the talk and getting her done since 1900. And their product that we're going to be playing with for this video is going to be this little world famous L series 3-jaw coupling. I have two of them, or they gave me two of them to play with here. We have a pilot bore on these two halves here, and we have a fixed bore on that pair of couplings there. Before we get into the closing and the K&T to go ahead and perform a simple bore and key, let's get into talking about why I'm here wearing their shirt and doing a small job and demonstration on their couplings. Alright, the reason why we're giving a video on these couplings is sometime you might come across where the size you need to put a coupling or adapt a coupling to is either not a stock size. It might be an oddball, might be somebody's off the wall dimension or turning that they've done. You might have an undersized shaft that you have to machine something custom to, but you could take a pilot and you can bore it right to that size, and that's kind of what we're doing right here. But you might also have a pre-bored coupling sitting on the shelf, and it's a Saturday or Sunday, and you're not going to get one, and you need to get going on your operation. What the machine or whatever you're working on is got to be turning. So you need to get her done, and what you're going to do is you'll be able to take one and open it up from an undersize out to the size you need, and then rekey it and then put it into use, and you're saving the dollars on your run. That's why I'm giving you a demonstration here, is so that you know that you can. Alright, so Lovejoy was established in 1900. That makes this their 115th anniversary this year. The family that owns Lovejoy is also celebrating an anniversary of 105 years. Now back in 1912, William Dangle purchased Lovejoy company, and then right around 1915 he purchased the real estate. So I think that's where, when he owned both halves of it, that's where they're holding the real deal anniversary recording there. The little coupling here that we're actually going to be playing with is nearly 9 decades old, and it's celebrating its 88th anniversary, and that was purchased from Louis Ricefield, and Lovejoy first called that the LR coupling. And the LR coupling didn't have the modern spiders that they have nowadays. They kind of started out with a leather and laminated type of spider, and they evolved from there. The first distributor of the Lovejoy coupling came about in 1928, and that company is still around, and the Lovejoy coupling is still in this catalog. Alright, so Granger has it, but there's plenty of other catalogs as well. MSC actually has a spot in their catalog, and so you can still procure Lovejoys anywhere around the world. All right, a couple years after they established distributorship and things were rocking and rolling, the Great Depression came on. October 21st, 1929 is called Black Tuesday. Stock market crashed and everybody went into the hole, started shrinking back, things like that. By 1931, Lovejoy shrunk back everything that they had except for this 3-jaw coupling, renamed their business Lovejoy Flexible Coupling Company. Say that a whole bunch of times real fast. And continued on and made it through that tight time and started building things slowly back up after, you know, it took I think 2 decades or so to start getting back on the road again. And in 1951, Ray Giegerich, I believe is his name, the pronunciation on his name, is German background, and it's a German spelling, so I'm not right there. But he redesigned the coupling that we now know as the L-series coupling. And in 1953, his redesign went into full production, and then the thing just really started taking off from there. All right, in the late 60s, Pat Hennessey was really into the sintering process. Sintering is forming shapes of metal with powder under pressure and heat. And in 1970, they produced the first sintered coupling, and that's what we have here. And it is very machinable, workable, holds up to all the strengths, the torsions, the impacts, everything else that we asked for this coupling to do for us today is now secure and is in the sintered form. That's kind of the basis of the major changing history that I researched in here at the start of my project. And the unique thing about this whole company is since the 1900s up to now, it has been home based in the United States. They do have other branches of Lovejoy and other countries, but this product here and the home base of Lovejoy had stayed in America. It did not go trampsing off to cheapo land. So the two plants that Lovejoy has here in the United States still are located at Downer Grove, Illinois, and South Haven, Michigan. All right, and hats off to you guys. Every single one of your couplings I've ever come in contact with, I've enjoyed the closeness and the tolerance that, and we're going to get into talking with that here shortly. But my hat's off to you, and happy anniversary. All right, guys, let's get set up, and we're going to grab one of these couplings and we're going to get on over here into the lathe, and we're going to get set up, and we're going to start boring while we're talking. All right, let's go ahead and let's pop our 2 coupling halves apart here, and let's take a look at these spiders here, just for noticing that we have 2 spiders. This is a SOX Buna rubber solid coupling. The shaft has got to be set flush with these couplings, but you'll be able to slide the couplings back and on the shaft if there's room to slide on the shaft, and then you can pull your spider out, bring it back in here, and you can change out your spider. Some applications come in where your shaft is set. You might have a C-face adapter and you only have a 1/4 inch or 1/8 of an inch of butting those 2 shafts together. They need to be able to transfer or go through the center of your open spider. And this is a urethane spider. Now this urethane material here is 1.5 times greater torque rating than Buna rubber, but it's harder and it's not as good on stop and go applications or oscillating applications. This would be the one that you would want. But if it's going to go on and run for long periods of time, the urethane is a greater torque. You can have a slowdown and a gradual increase when you got a load on it, and this one will handle it more. But the start and stop and the oscillating, it's not as good. There is another spider that they make out of Hytrel material, is I believe the name of it, and it's 2.5 times stronger on the torque rating than the Buna. All right, so as far as our spiders, those are the spiders that we have here for demo. Now our urethane spider is going to gauge our bore for these couplings here that we're going to go ahead and we're going to open up the pilot. And we went ahead and we're checking this, and we're 1 inch 257, or just a little over 31.5 millimeters. We're going to go ahead and we're going to bore one of these out at 1 inch, and we'll bore out the other one at 1.25 inches, just so we have two different bores to play with, and we'll have two different size keyways to bore. Now this is USA customary inch clearance fit and interference fit bore and keyway standards. So this is basically a general outline of good practice, and I think this is good practice. I practice this exact amounts on the average of what I'm fitting up on either a slip-on or a press fit, or a shrink, heat shrink fit is what I actually like to call it. Here's your inch and 5/8 fractional. There's your decimal there, and here they give you a clearance bore, and then you got a +1 / minus nothing. So 625 to 626 is the decimal on your clearance. On interference bore, they got -1 / minus 2 thousandths. So there's your 1 5/8 there, 16250 to 1623 to 1624. So it's 1 to 2 thousandths under for your interference fits there. And then your keyways here, it normally gets 3/8 there, and your height that is usually half of your width, plus a couple thousandths. You never want to be key bound, and you want to make sure, because if you could have a good fit on the bore for your shaft and your coupling, but you could have a key that's not deep enough, and you could have an interference fit there, and you'll play havoc getting it on. All right, get our snap gauges here. I'm just going to put them in here. All right, 1 inch 626. All right, so that should slip right over the shaft perfectly fine. And let's just see what the 1 7/8 one here. Same thing there, 1/1000th over the nominal. So these are set to be a slip over onto a shaft with thousandths clearance total if the shaft is right on the nominal. The tolerances of the shaft may be plus or minus a little bit. These definitely will slip over a nominal shaft. Okay, now that we've kind of touched on Lovejoy's tolerances of their own couplings and the samples that we have, and we're going to go ahead and we're going to take and we're going to set these up in the lathe now. So I'm going to take this over to the lathe. We're going to get this set up, and we're going to bore one of these out to 1 inch, and we're going to bore one out to 1.25 inches. All right, ever since the 70s, 1970 was their first production of sintered fabricated couplings, and it's amazing how accurate they actually are. That surface that's formed by the compression and in the die there, and then when they push it out, it does have like extruded lines on there. I always kind of wondered how these things were made. I'll drop in a link at the end of the video, kind of giving you a history video, and there's another link that I'll probably add in there as well. Anyway, I wish I actually had a precision 6-jaw. Would be ideal for setting this up and boring it. A better quality 3-jaw would be nice as well. Pie jaws, you could run pie jaws, and you can actually turn them to hold that diameter and register that face in the pie jaws. You could put 4-jaw in here and you could dial it in. I'm going to go ahead and slip this into my jaw, my 3-jaw here, and I'm going to see if I can manipulate this in. My tolerance would be 1/1000th on this face and 1/1000th or less on the bore. Alright, so I'm going to go ahead and get this in here, and I'm going to get the indicator set up here, and I'm going to bring you in close and witness the run out that I have on here before we start cutting it. Alright, we got that one set on 0. We don't really have to have them on 0, but I'll put it on 0. Let's rotate it around here, and now each one of those lines is a 0.5 on that indicator, and each one of these is 1/1000. Now it has a little dip there, and this one here, you know, it's kind of hard to tell. If I just go into 3 jaws there, so there's 0. There's a -0.5. There's -1. And there's 0. So I think that's within 1/1000 on that face. I'm 3-pointing it. Alright, and the other indicator, I'm running about a 0.5 on that bore. Alright, now also too, you got to remember this. Before you bore these things out, this ain't the right Allen, but it's going to come out anyway. Make sure you remove the Allen, and always look down in there and make sure that somebody didn't put 2 Allens. Sometimes Allens are, you know, they don't put 2 in this, but sometimes the guys in the fields will double up on their Allens because they're going to, it's a way of locking that bottom Allen in there. Alright, I think we're ready to go ahead and bring in our tailstock. We'll open up the bore a little bit with a drill, and then we're going to go ahead and set up a high-speed bit, and we'll come in and we're going to give a finished bore on this, and we're going to do one at 1 inch and one at 1.25 inches. I think we're gonna shoot. My normal practice is to shoot for the smaller of the two first. If you get it right on the money, then you've got one out of the way. You practice on it. And if it happens to be you overshoot it, then you could take it to the next size, and at least it gives you one chance. It gives you a double chance on your first one. Your last one, no matter what, if you don't get it right, you don't get it right. Okay, we got a 7/8 drill here, and it is pretty sharp. I just got a little cut there. All I was doing was taking a rag and wiping it through, and it actually cut a hole right through the rag and into my skin there a little bit. And you got to be careful handling your tools. And I don't even think it's gonna be bad enough to have a band-aid. So anyway, this is a 7/8 drill bit, and we're bringing it in here close. And I have a certain place where I like to kind of start my my spindle there, so I can get through there without it hanging out quite a bit. Roll it around, make sure everything is clear. Now this centered material cuts like cast iron, and it flakes off of there. It's not real hard stuff to machine, so you do have to treat it somewhat gentle as far as not sucking a bit in on it sometimes. So anyway, back to it. I'm holding the brake slightly as I go through. We just went through that set screw area. You can hear the intermittent. Now if you had the right size reamer, you could, with a nice round hole like this, you could ream it. And I probably do have a reamer, but I'm going to go ahead and I'm going to bore it anyway. I sometimes if a reamer doesn't quite cut right, or it's a little bit dull, gives you a little bit oversized sometimes. Alright, see what we got there on our hole. .877. So by the digital calipers, it actually shows that it was 0.02 over the nominal. Okay, we're going to go ahead and double check it with our snap gauges. Okay, and I'm getting 876, so I'm only maybe a couple tenths over that, but very close. Okay, we got this tight here. We took our hand and our finger back here. We can feel where it comes out past the back here. We set our travel dial for 0. We look over the top. We got clearance here. We can rotate it without hearing it rub or scrape. All right, so we're good to go here now. Okay, and we're going to go ahead and put a dashboard gauge up here so that we can have a visual on a dial. And we can turn this up a little bit. We got a touch. Now we knew we had like 24 or so, and I just touched it. It probably could be like 2. So my regular practice is to go ahead and take, we'll take 5. And we'll find out where we're at after that. I go ahead and I reset 0 on both my dials. And I let it run through. Okay, after our first pass through here, but we did take 5, and we're right now we're at 890. So our touch off plus, you know, we're at like 89 or so. All right, we can go ahead and we can take 20 now. We'll go for 25. That should put us up at 940, 939, 940. Okay, and this is a pretty coarse feed here. We're going to slow it down as far as the feed after this cut here. And you can see that it cut on its backstroke there. Sometimes I get that inside there. $9.34. We were 5 thousandths off on our quick educated guess there. All right, this is 15 with a finer feed. That bore feels a lot better in there, a little smoother. That's looking like 87. So it looks like 13 more to go for finish size. 14 at 13 to 14. And we're going to go with the tolerance. We'll look at the book here shortly because it shows that they use the US standard fits, and they list them in their book, and it's +1 minus nothing. So we're at 87. So it's 13 to 14 thousandths total that I've got to go to get my bore here. So I'm gonna shoot for 6.5. I'll shoot for 13, and if I have to, I can lightly polish it to get that other 0.5 thousandths if I need it. If I had the shaft, I would be measuring the shaft and I would be deciding on the fit myself. If you're gonna bore out to a standard or to a drawing, you kind of got to go use your instruments and take it to your instrument measurement and fall within your tolerance. But of course, if you have your own shaft, you can mic that and you can shoot for the best fit for your shaft. All right, I'm going to take 6.5 just to try to go to a dimension by the book. Now I cranked it in before I pulled out so that I wouldn't be putting a spring touch on the back side there. That looks real nice. And we'll come up with the right dimension here. And I'm right at 1 inch, just under 1/1000th. All right, so I fell right in where I needed to fall into, and it was a good thing I shot for a little bit on the lower side. Sometimes you have a little bit of tool pressure on your instruments or engagement in a way that things have a little bit of pressure on your dial. This thing has got a lot of slop in it. You got to work a lot. On the older machines, you got to compensate for a lot of things. You use it, you learn it, you know how much it has on it, and you do a lot of compensating. A lot of the newer stuff, you crank it exactly where it wants to go, it goes. A lot of things that are digital, they're all zero backlash, and they can take things right to where they're supposed to be, except for when you lose the tip on your insert. Okay? But this is how you go about sizing up a coupling if you need to change or increase or create a bore of size special to your application. Okay, we're happy with our 1-inch bore, and we're going to go ahead, take our bit, put it up here. We're going to change out. We're going to just put in our regular D&MP here, and we're going to go ahead and swing it around. And I'm just using the edge of this to go ahead and break so that we don't have a real sharp edge right here. I want some kind of a chamfer in there. If you look at their stock bore, they actually do give it a slight bit of a chamfer in here. I don't think it needs much, just a little tiny bit like that. And then I do like to take a little piece of paper and just massage that a little bit, just so it doesn't have any raised areas. I like that. That's nice. All right, now we're ready to go ahead and throw the next one in. Indicate it in the same as we did this, and then we'll have both of them bored, and we'll be ready to go over and put some keyways in. Now let me pull this out. We'll blow this free. Now this side here, we can reach in with just a burr like this. Just go around that edge. That'll be fine. We actually might need to step up to our other snap gauge there. I'm actually measuring about a 8/10 under. I'm going to grab my larger snap gauges here. I'm measuring the same thing, 1,000 under, and we can go to 1,000ths over. I'm going to sneak into the same number. Alright, we should be a little closer here now. Okay, we're 1/2 thousandths over the nominal. 1 inch, 250 and a half, or 250 and 5/10. Excellent. The Sharpie, wiping it on there, really lets you sneak up sometimes. I mean, you can see I was just barely, it doesn't even look like a chip. And I'll vacuum all this out of here before I do any running around. Alright, let's go ahead and we're going to break this next area. Alright, nice. Alright, now we're going to go ahead and we're going to remove this. We'll clean up this mess here. And then we're going to go get the K&T set up to go ahead and broach the two keys in there. We're going to put a 5/16 key in this one here, standard for 1.25 inch, and we're going to put a 1/4 inch in on the 1 inch bore. Alright, I think we got all of our gear over here. We're set up. We got the jumping jack head up here mounted on the machine. We're going to double check on the alignment for the ram. After that, then we'll be ready to go. We're going to do the 1 inch bore coupling here first, and we're going to put a 1/4 inch keyway in it. I put the 1.25 inch over on the hydraulic press out of the way, and we're going to get set up on that. Now the reason why we're using this is just because I think at times with the sintered and also sometimes on ductile iron, when you're pushing a broach through and you have and this is the other way that we have shown this method on some of our other items there, broach and keyways, and that's using a broach guide and a push broach, pushing the broach through each one of these teeth, grab a little bit more material, it passes through, we add in a shim, and then push it through again, and until we get to the depth of coupling that we want, or depth of keyway. And this was a little cocked in there, so it was looking a little high. Okay. Sometimes on this material and also ductile iron, the stack of shims, sometimes the tool pressure on the cutter will want to dig in a little bit, and I've had, not every time, I've just had my share of grabs and actually just sucking it in a little bit, and then it gives you on the bottom side of the far side of your push on your pass with your broach, you end up taking out a little bit more depth than you want to. So I'm going to set that over there out of the way, and we're going to get in here. We got busy. We actually have a couple different things. I got this is just a transfer punch, and I made a no-go gauge to do alignment. We have our push cutter, which is 1/4 inch wide, and it'll be just a straight in plunge for the 1/4 inch key, and then we'll sidestep it to do the 5/16 key. I have a 5/16 rod that will stick into the set screw hole so that we get alignment square with the machine, and we'll be putting the keyway straight in line with that. We're going to be using a couple right height mill clamps made by James Morton. These are some oldies, but they're nice low profile. They'll get in there and support that, and we'll have plenty of clearance in here. And straight edge and a couple other things that we're going to need. I think we're ready and set to go. All right, so let's move you in here a little bit. I'm going to go ahead and check the tram on the head, make sure that that's all square first, and then we'll start locating the part on the table. And then after that, we'll locate the angle or position of the tool bit, and then we're going to set up something that was made for us by one of our worthy nominations in the toolbox giveaway, and we're going to show you what he made us here on our for our K&T, and we're going to put it to use today. I'm going to hold my light behind here, and you can see how it's tight up here and gap down here. Let me zoom you in a little bit on that. Okay, you can see it's gap there and tighter up here. All right, now when we go to the other side, okay, now you can see the gap up at the top, and then a lot less at the bottom. Okay, so we're going to loosen up the 4 bolts to pivot the head, and we're going to go ahead, and we could do it and use we can use the light behind here and just get a good eyeball on it, check it on both sides. We can also take a mag base, and we can put the dial indicator here, and we can move the table and knee up and down and dial this surface right here. We can actually do both of it. Anyway, I'm going to go ahead and I'm going to go ahead and position this and change it, but I just wanted to show you that I had used this in the horizontal position, and I just swiveled it around quickly to put it in this position to stow it away, and I just know to automatically check it, even though it stares, and you stare over here at the outside edge of it, and it looks like it's in line, but it's really not. Okay, these aren't even, you know, I can tell because those aren't even real tight. They're not really snug down. They were just enough to hold it. All right, this is where I like my rawhide mallet here, and I try not to stay anywhere thin. Like there's a thin web of the casting. Try to stay away from all of that. You just want to grab something that's solid. Now we know that it's going to want to go this way here, so I'm actually, I know it's loose, so I'm just going to use the ram itself. Okay, still looks like it's slightly gapped on the top, and slightly gapped on the bottom still. All right, that looks pretty straight. I'm gonna go ahead and I'm gonna put this right here, tighten that just a little bit. We're gonna grab a mag base and an indicator, and we're gonna put it up here. We're gonna run this up and down real quick. Okay, I'm gonna fire up the mill, and I think everything else is locked. In and out, there we go. All right, now I'm just gonna control the table up and down so that I can travel along that edge. That's the guiding edge of the ram. Okay, I'm gonna go ahead and bump it in just a little bit. There we go. I just wanted to show you that checking the light clearance behind there is pretty accurate with the flashlight, and I probably had a little 2% of luck in there as well, and I'm pretty happy with the straight alignment we have for the head. All right, so let's start setting up our part now. All right, we got this in neutral so that we can control the cranking up and down here by hand. All right, now we need to position, we want to position our hub in here so that the threaded hole is in line with the key, because that's the original design, is to go ahead and put the set screw and keyway in line with each other. Sometimes some other applications I like to actually oppose the set screw in another area and dimple it into the shaft, but for most cases where you want to slide and change out your spiders, the set screw on top of the key seems to be less interference with dimpling into the shaft material itself. All right, I'm going to go for this hole to be over here only because I know that then I'm going to be splitting the line with my clamps. So what I'm going to do is go ahead and I'm going to put my two clamps together here real quick, slide those into place. And the T-nut's already on here. Okay, spin a couple nuts on here. All right, I got two blocks here just because I want, instead of this foot here coming down and worrying about it where it's at there, and also adjust the height so that this is not extremely low and I'm getting a full rock action off of the top of these clamps. These are really nice clamps, but you always got to just double check and make sure that you're drawn straight down on the rocker arm, and both of these positions are in the range. There's a certain range that this thing will set in there, and that's all you need to do is just be in that range. Kind of happy with that. Okay, now we're going to come off of the back ways here with a straight edge, and we're just going to rotate this until we're in line like we did the vertical head, tramming that in. Everything in a stress-free mode. That looks pretty good. All right, we'll go ahead and we'll lock down our hub now. All right, we're not going anywhere. That's in good position. All right, now we need to create this cutter, the center of that bore, and this cutter straight in line with where we want the keyway to be. Our first step is to go ahead and put in our transfer punch here, and we have this no-go gauge slider here that just barely slides in there. This diameter is the round of all of our tooling that we have in there, which is 1/2 inch. And we're gonna lower this down here. Excuse me, we don't have to do that. That's why I put this thing in neutral, so I can crank this thing up. Okay, I'm going to bring it down slowly. Make sure that there's the full down stroke. Okay, we know that we're not going to be hitting this piece here. Slight little tension on our two draw nuts just so the rod is sturdy. Did you notice that? I put that on upside down. And I made it so it can go on either side. Alright, now I should just be able to unlock my table here and slide this, or adjust slightly in, slightly over there. Okay, this slides down in there, slides up. I'm happy with that. Okay, so we're gonna set our dials at 0 so that we've got all those in position there. All right, there's 0. There's 0. Up and down, we don't have to have 0, but in fact I'll leave that one a little bit loose there. Okay, I'm happy with that. Alright, so we're going to lift this out, we're going to get the cutter in there, and then we're going to get the cutter straight in line or square with the axis, meaning this is a 1/4 inch, so we want to make sure that it's going down the center of the travel of our alignment right here, and not angled over to the starboard or the port side. Okay, we got this bit in here and we can rotate this to get the alignment. We want to find out. This machine surfaces on the side. We've proven that this is 947 from both sides. So, and we set this at 947, and we came in here and we scooted this thing easily along each side here. So we take 0.0, or excuse me, clear. We take 0.947 and we add in 1/8 of an inch, because this is a 1/4 inch width, this is a 1/2 inch, 1/8 the 1/4 width, 1/8 on this side here. That makes it 1 inch 72. So we go ahead, we just double check and make sure always that we zero out. So we're going 1 inch 72. All right, now we're going to go ahead and we're going to set our square, because we're going to use our square to set that height there. Meow. I'll let you out in a second. Okay. Now we put this down here at the tool bit here, and we swing it to till the tool bit hits the side here. Ah, damn. Okay, go. Alright, and we double check it on this side here. Alright, it was a little tight, reach across here and come down here. So what we did is, this is equal on both sides. And we did it by testing. So we come down here so that we can hold this straight here. And we can slide this right past it. We can almost feel it. And we come over here to the other side here. And same thing. A little less touch, but I can't see no light between there. So I just wanted to double check it for another reason, and I trust this here because it's more, this is ground and that's ground here, but this one here is held in by this and the V, which is pretty close. I mean, I've taken the depth and reading across here, and the same thing over here, but it just has a little tiny bit of interference, and I think it was messing me up. But this definitely lets you slide the square right past the tip, and you can feel that I'm just as from here to there, here to here, and these were all precisionally made. I mean, I verified it right now by doing what I just did, that this center line and this ram is 100% in line. All right, so we're centered to the hole, cutter centered to the line of radius we want. We have the set screw pointing square off of the table. Everything's ready and set to go. All right, we got one other feature we're going to add, and I'm going to grab a hold of that right now. Okay, let's go ahead and we're going to bring it up now so we can set the depth. We're all the way down on our stroke, so I just have to look underneath here. Okay. That looks pretty good. All right, let's put it in gear. Okay, you notice that it goes down faster than, or I mean, it goes down slower than it returns. And that all has to do with the crank and the way they designed the crank in here, in the position of the pin slide, and whether we have the machine in forward or reverse determines whether we can change that to pull in the fast and then push in the slow. Okay, this is my new gadget here. Nice little V groove right here, and a screw that's adjustable in and out, and it's set for the width of the ways here. Toby Zastrow made this for me, and he brought it up when he came up and picked up the toolbox, and it's made to just sit right on your ways, and the one uniform place that's always comfortable, and as long as you don't move or lift this thing up and down, your needle will stay the same. And we are going to be keeping this locked so it stays in that one position there. We're centered, so all I need to do is put a load on here with enough travel and slightly tension it, set this at 0. And actually I could set the main dial too at I can set it at 1, which would be halfway of its whole travel, but at least it gives me a 0 point. Okay, so 0, and there, of course I'm going to reset this when I do touch, but I just want to show you how it mounts on here and mounts against and sets against there. So now I can use my dial, but I can also verify it with this dial here. Now, as far as these dials here, I had it set 0 to be centered there but I'm going to be setting this where I'm going to touch off, because I want to be able to read what I'm actually feeding in while we're machining, so I know the depth of this keyway that we're putting in here. Alright, so I'm going to bring you in closer so that you can actually see the touch off, and you can read probably both of these at the same time. Alright, here we go. We're going to start cycling. Alright, and we're going to back out slightly, a little bit at a time. And I'm just looking for the touch off on the coupling itself. There we go. We're touching on both sides right there. Let me stop it. All right. You can see that both sides of that cutter are touching. All right. We're gonna setting our indicator here at 1. Right there. That's close enough to the 1 to know that I'm on that 1. I'm going to set that one at 0. So now we can gauge our depth from this spot in. Okay, here we go. One last setting of the dial here, just so we got it in there. I only feed it right at the point of being right at the beginning of the stroke. Okay. Looking pretty good. We're 50 thousandths now. Looks like it's cutting pretty good. I'm going to stop it for a minute so I can look in. Looks like a nice cut in there. Now I'm just going to make a little test here. By just putting just a tiny bit of oil on that surface. I want to see the difference between with and without on that surface of the cut itself. And I stopped it there. I give it a couple thousandths, a little whip of oil. Okay. Maybe just a little tiny bit of a glossy, but we're going to go ahead and we're going to let it run. I'm going to dab it a little bit as we're cutting. I'm going to see if it glossens up a little bit. There's 90 thousandths, 95. There's 100 thousandths. You know, I can't see any difference with or without. The sides do look nice and straight. Okay, so we got 25 to be exactly 1/2. I like to do a 1/4 inch key. I like to do it at least 30, 35 thousand. But we'll shoot for 30. We know that we were touching off pretty good. The thing was nice and square. almost just like a shaper. Now a shaper with a clapper box, you can feed it on as early as on the way back, but on this one here you don't want it to rub anything extra. So you try to do it when it's just out of the air before it goes back in. So when you make your advancement of depth of cut. All right, we're just taking a couple spring cuts, and see here we're at 132 thousandths. And that's a nice finish in there. Okay. Let's shut it off here. I have a piece of key stock here, and I want to slip this in here. There you go. Nice, nice fit. Just slips in. It's not real tight. I can push it, but it stays in there without falling out. And it's just a piece of regular bronze key stock. In fact, it's even slightly radius. I think I was going to fit it up for one keyway with a radius end mill cut, but it never was used. We're going to go ahead and get this coupling changed out with the other coupling, and then we'll be using the guide. We're going to do everything exactly the same as we did to set this up. We already have the preset for the tool bit, so it won't take us no long to go ahead and break this one down and go ahead and swap out the couplings. We got this clamped down, and we already have it straight in line there like our other one there. So I just want to show you that I actually got this to slip in here. It's a little sticky just like the other one, but we're right in there. So we're center. I'm getting ready to bring this out. There we go. Okay, and I'm going to change out our cutter now. Or change to our cutter, I should say. Okay, that gives me the amount of flat that I want to have here to go ahead and spin it and set that. Okay, we're set there. All right, we need to be able to come over to our two sides so that when we come in, we'll be touching at the corner, so we'll know our depth from our corner. Otherwise, we're going to be falsely reading a little bit low, and we're actually going to be cutting it too deep. We're more comfortable putting a 5/16 keyway in a piece of or an 1 1/4 or 1 1/4 shaft. And also too, I want to use this as an example of sidestepping a cutter. Because Toby made me this piece right here and gave me the one axis here. I just thought this was going to be really slick, and I think this will work out here. Let me see if we can put this on here. I think we slide this on over in here. So I can use this block as a stop going in and out this way here, and I got this one reading out this way here. Not quite straight here. Doesn't have to be 100%, but real close on the actuation going in and out, the axis pointing. All right. The straighter you have it, the less deflection or difference you're going to have. But a minute degree, 2 degrees, or whatever on the angle there, you're not going to be able to notice the difference on your measurements as far as your regular indicator. It's on a spring piece like this. All right, let's fire it off. And now we know we got a 1/4 inch there. We're going to go 5/16, so we need to sidestep our 1/4 inch cutter 32nd each way, and then that'll give us our 16th that we need to increase the width. So by cranking it over 32 in this direction here. Alright, now we can come in and we'll touch, and we should be able to touch at the same 0 factor on the other side as well. We'll test that theory out here as well. Okay, give us some feed here, or speed. And we may have to adjust our height. I don't think we didn't adjust our height of our stroke. So we're going to crank up the table here. Okay, we're just protruded through the bottom. That looks good, that looks good. Make a cycle. Okay, we're good. Alright, now we're going to bring a light in here so we can see it a little better. A little easier to do this than it is to hand crank it and just kind of get an estimate of it. I'm just trying to catch a couple at a time. Okay, I'm just touching it. Okay, and that line, very faint line, going all the way down. Okay, and this is the other, the 0.1 and 0. All right, so now we should be able to come across to our 32 on the other side. And we got a line on that side now. About the same width and broadness of that line. Okay, we're going to go into our 0, and then we're going to come and we're going to do each side at different times. Now the difference between touching at 0 there and if we would have went straight in and touched at 0 at the quarter, we'll be able to read that as well. Okay, it's about 8 thousandths difference of depth reading on the 1 1/4 radius versus the 5/16 or the 1/4 inch key. Okay, 5/16 will be 532 on the half size there, and 532 is 156. So we're going to want to at least take it to 160. Okay, there's the 160. Okay, we're bringing it all the way back out to past the 0 so we can start fresh. Now we're going to kick it to the 32 in the first direction there. Alright, now we're just going to ease it in, and we're going to cut down to one side till we get down to the depth. Another 15. I'm taking like 5 a pass. Okay, there, we're sitting down at the bottom again. And we're letting it just spring cut there. Okay. All right, now we're going to go ahead bring it to the 32 the other direction. It's actually when I say 32, it's 31.25 or whatever it is, and $15. Okay, and we're at the 60 now. We'll let it spring cut. Okay. All right, let's get a little air. All right, here's a 5/16 key. Okay, it starts in little teat. Well, measures right on the money. All right, so I'm going to go ahead and I'm going to take an extra thousandths. I do see little tiny shavings in there. Oh yeah, okay. I'm liking that. She's actually starting to stick in there. And I mean, I'm having to reach in here. Let me turn it sideways. The 1/4 inch I took in and deburred the burr on it, so I think I'm going to do that with this. I went in the other room and deburred that. All right, and it's almost fitting all the way in there. See that? I can actually start pushing it in almost to the top there. This might actually be just a little spot on that top on that side there. I'm going to go ahead and let's take it back over to that side there. It just fits so good everywhere else. It was like a little tight, but only at the very top there. And I already made a spring cut going in on the other side there, so I just want to make sure that this initiated side over here wasn't pushing over. Doesn't take that much longer. See, if we had a 5/16, it would be just like the other 1/4 inch tool bit, just going straight in and plunging in like a regular keyway cutter. I kind of do it this way here. It reminds me of a couple of the tabletop keyway cutters that we've had over the years, or I've had the pleasure of using over the years. Okay, I'm not going to fuss with it anymore. I like that. Just a little tiny tight at the very top, and I can firmly push it into the bottom down there. I'm happy with that. Well, I went ahead and I massaged this one keyway here at the mouth, and you can see, okay, I mean, it will, if you tap it down it will fall out, but that's a good fit on a keyway. I like that. And same way with this one here. So they fit in there fine. And the spider, and you can see through the bore. Like I said before, I'm giving you a demo on being able to work with these couplings. It's not something that you need to be afraid of. You can conquer a bore and a rekey, and you can get the job done and get these things, get your machinery in operation. And like I said, also if you have one that's been sitting around, or if you're in that pinch where you can't get one the right size and at the right time, go ahead and modify an existing one. Even with the key in here, it's a very machinable material, and you can get through the interrupted cut by just skimming it a little bit, and then go ahead and not everybody's got a jumping jack or a slotting head like this, but you know, the push broaches, there's plenty of keyway broaching videos online. Even Lovejoy has a couple special topics, web pages, and videos on that as well. I thank Lovejoy for the beautiful hardback book. I learned a lot. I hope I explained at the beginning of my video the history as I read it, and technical information. I want you guys to know that anybody out there that needs help with their engineering solutions and worldwide support, Lovejoy will give you. Other than that, I hope it was just another nice visit into Turn Right Machine Works, and I hope I gave you a few tips that you can put to use. All right, till the next video, get her done.